cold, we'll get a cold shut. We pour the thin stuff first. Face shield at full temperature. Okay, I'm lowering a little bit. Release the finger gently. Now, hold a second. I locate on my weights and center the hole in the hole of the weight. It's a little bit hard to see the hole, but if I know that the sprue is very much in the center, I can still hit it accurately. Okay, we come back, set it down. Go ahead and pull your finger back. Okay, that pour went smoothly. We shouldn't need to have overflow and have it run out on our bottom boards and have it run out on the grading or on the sand. It's like, if it's full, it's not going to take any more. We're not going to squeeze any more in by still pouring. And once we see it fill up, we stop. The other one, our bigger base, I'm concerned about too much heat in the metal. If you look at this metal, you won't be walking around like I am, or talking, or bright orange. Way too hot. If we pour it that hot, it's going to do all its cooling in there, and it's going to do a massive amount of shrink. And we don't want to do that. So we want to bring it down to the correct pour temperature, which is certainly not that hot. So what we're doing, we're watching our crucible, and this would be a time when you could legally flip yours up to see what's going on. You want to see the color of the crucible. It's got some orange to it. It's going to go all the way back to that silver gray color before it took the heat. All right? Okay, 1 second. Okay, that's still too hot, so we let that cool off. We can take a piece and skim it, or heat sink. There's the, see the shape of that? We didn't shape it that way. Steel came off of that from this job. It dissolved slowly over time into our metal. So it does happen. All right, go ahead and do some stirring. We don't want to bang it around the crucible. The crucible is ceramic. We can break it. You should watch your crucibles for cracks. All right? They get retired once they get a crack in them. I had one a couple semesters ago. We were pouring bronze and aluminum. You can't use the crucibles interchangeably. You have to have a bronze crucible and an aluminum one. And I set the bronze over there by the door to cool off while we poured aluminum. The air from the door cooled one side of the crucible faster than the other, and it cracked it. I had to throw it away. That's the end of it. Typically, especially if you're in a school situation, you decide it's done for, you go out, you take a hammer to it and break it. That way nobody else uses it. Okay, he's drawing some heat off of it. Again, he's trying not to get sloppy and spill stuff. We don't want drips if we can help it. You can take that out. It's only going to absorb so much heat. It's not going to do near enough later on. We got a little bit of a snot hanging off our spout over here. You can take our skimmer and catch that knot. That thing will stick to the outside of the crucible. We also want to avoid getting metal into the furnace. Right? That puck that's in there, it'll stick to the bottom. That causes a problem. Get metal in there, it'll stick to the bottom. Right? Eventually, the bottom of your furnace will start filling in, and then you can't even close your lid. Right? So be careful. Back to a reasonable heat on the outside of the crucible. We skim the top. What we're looking for is the color of the metal. It's not orange, it's more of a mercury. It doesn't have to be complete mercury, but we want to get it down to that. We also want to have enough metal in the crucible. We don't take so much out that we don't get a full pour. We can easily get the face shield and the base. We could probably get 2 face shields and a base in a single pour. We don't have enough metal to do 2 bases in a single pour. Our metal, for the record, is really pretty clean stuff. It all comes from a known source. We purchased it. Signs on our doors, posters outside there, talk about our preheat, our concern for moisture. We're trying to stay safe that way. We're skimming out of habit. A lot of what's in our slag bucket is good aluminum. If we had a big crucible, we could probably pour that down, skip off some more slag, and recycle that. But, you get into the public schools, you might do some recycling, and you'll get different degrees of slag depending on how dirty your stuff is. You can use this brick too. Look how long it's taken me to get down to temperature. But I am keeping my hand on stuff so I know and feel if something's moving before I even see it. Okay, I'm pouring a little slower than I should. That stream should be about the thickness of your thumb. Okay, we're keeping that crucible as close to the pour, as close to the flask, as close to the mold, the ingot mold, as we can. Minimize splash that way. We'll put her in like this. Actually, how thick are we in there? Yeah, you can scrape that out. Sometimes you can scrape out the crucible like we are now to clean off the sides. Other times you may not need to. If somebody's going to pour right after you, you probably don't have to. If somebody else wants to pour like as soon as possible, you can go without even filling the ingot molds. Put the crucible with metal in it, back in there, and fire it up again. And then add more metal. At the end of the day, though, we will never put a crucible in there with metal and let it solidify. The expansion rate of the ceramic compared to expansion rate of aluminum, you put fire to it when it's solid, and it's probably going to break the crucible. So you always want to have an empty crucible when you're done for the day. We also still put cardboard underneath the crucible. Right over here behind the door, we have a stock of cardboard. So just put one in before you start up. Coming unravel. I've got this. You're going to all we want done. Okay, slag. We've got a crucible about to be retired.
Yep.
Got a crack right through there. A couple others start. You're a teacher with a public school and kids that are 15 years old, you should probably break it. Alright? You never live through a court case if somebody gets hurt and the kid says, oh, I remember that thing being cracked before we used it. It's like, your job's gone. Okay? So, yeah, this one, we might use it for another meeting. Okay, first step.
Turn on the vents.
Okay, ventilation system, the switch is right here. The light switch is over there. So you turn on the ventilation.
And And then the next step is going to be make sure that the air setting is set between 5 or 6 and 7.
Okay? The round black knob stays where it is. We usually use, that's like in a carburetor or air mixture. 6.5 is a good spot. Okay? We prepare our furnace. All right. If the furnace is cold, you can loosely fill it with metal. And you put your cardboard in, and you put your crucible in there. All right? Leave the lid open. Right? Okay?
And once all that's right, air is correct, you're going to hold the start button, it's the black one, for about 5 seconds until you hear the solenoid inside click.
Start actually doesn't take the 5 seconds. The start will fire things up. You can push it and it'll run. I'm confusing you, I know. You'll hear the blower running in there. All right. There is a valve in there that controls that gas flow. We can dress down a little bit, a little warm. Once things start running, there's a timer on there. 5 seconds it starts with the gas and the spark at the same time. You'll hear the solenoid click on. That's when you turn the gas valve from fully shut to fully on. I kind of run this the way I run my home grill. It's either off or it's full heat. And now I've got something predictable that I can work with. Going half gas here, I don't know how long it's going to take it to melt something. Well, I go with an unknown quantity. It's like, I'm going to try and save gas for the school. Yeah, I paid my tuition. I'm going to use all the gas I can. All right? So with the valve, the gas valve, it's either off completely, or once you hear that solenoid click in, and you got to turn it on. Right? You can do that right here. Blower coming up. Click. And you turn on the gas, it should light up. Shutting it down, turn off the gas first and hit the stop. Now there's an electric eye in there, like a little brain. If that eye doesn't see the flame, it shuts off the gas by itself. If you don't get your sequence right here, it's not going to light up for you. You get a little red light here on the dashboard that tells you we have to hit the reset button and try it again. Okay? Things will light up. Then you close the top. We don't want the top closed while you're blowing the gas in there. And then you're being slow to hit the spark when we blow the lid off. Never seen it happen, but it's plausible. Okay? So that's our light up procedure. As we need to, we can preheat metal on the lid. We have tongs for adding stuff to the melt. If it's small enough, we can go through the lid. Go ahead and close that. If it's small enough, we can take stuff through the lid and drop it in. Drop it as close to the melt as you can, because it will splash. Sometimes you get a little dot of metal coming up out of there. Right? If you got a bigger piece, you can open the lid and put it in. In both cases, use your face shield, use a pair of gloves, use a tongs. Public school, use the face shield, use the gloves, use the jacket, use the leggings, use the tongs. Okay? You don't want kids getting hurt. Okay? Okay, so we've got the light up taken care of. We've got the core. When we're done, we'll pick up our shank. Put that out of the way. If you come into the place and it looks like this, don't assume those molds are wet or cold. They may not be. If we have some odd pieces sitting over here, they are there because they were preheating on the lid and we decided not to use them. We'll pick them up. Right? If it's cold metal, it's over there in the bin.